All right, so this is from your IVT review worksheet, intermediate value theorem, and I think it's called intermediate value theorems and limits. So this is page 1. So we're going to be working out on notebook paper. So if you have paper, you're going to write on it. And it's very important that we follow the instructions. So use the definition of continuity to tell why each of the following graphs is not continuous at A. So let's remind ourselves of the definition of continuity. So the definition of continuity says these two things. It's continuous at A if the left and right hand limits are equal to each other and that is equal to a number. So it cannot be like when we approach infinity, which we can't really approach from both sides, but either way, that we're approaching infinity. That's not okay. So the left and right hand limits have to match. And where they match, the value, what that limit is equal to the value of the function at that point. Okay? And so that's our definition that we're working with. Left and right hand limits agree, and the value of the function. So those are the two things we need to talk about. So in this first one, it is not continuous because we're trying to show it's not continuous. And so with this first one, number 1, the limit, I'm going to call this f of a. I'm not going to call that f of a. I'm going to call this q, and this p, for lack of better names. So that one's q and the top one's p. So the limit as x approaches a from the left on this function, which we'll call f of x, is equal to q. And the limit as x approaches a from the right is equal to p of f of x is equal to p. And since they're not equal to each other, this is not continuous. So I would say this statement, the limit as x approaches a from the left is not equal, so that should be f of x, is not equal to the limit as the limit as x approaches a from the right of f of x. That's me using the definition. So the right and left hand limits don't agree. So there's my definition. On this one, the left and right hand limits agree. So the limit exists. So the limit as x approaches a, we'll call this one r, of f of x is r. It exists. Totally fine. But f of a is not equal to r because f of a is undefined. It does not exist. But it's not equal to r, which means that the limit as x approaches a of f of x is not equal to f of a. And so there's my continuity again. So we have our jump discontinuity here. We have a removable discontinuity here, and we've shown that that's not working. And this one, we also have a removable discontinuity, but we have a value of a. So this one, f of a did not exist. And this one, f of a does exist, but it is not equal to the limit. So we have the limits equal to, say, let's pick another letter, z. I haven't used z yet. And then the value of the function, let's call that w. And so the limit as x approaches a of f of x is equal to z, because the left and right hand limits are both approaching the same value. But the value of the function, f of a, is equal to w. And so that's not equal to z. And so then we go to the same reason that we have down here, that f of x is not equal to the limit as x approaches a of f of x, is not equal to f of a. So that's me using the definition of continuity to explain why they're not continuous. So none of these functions are continuous for different reasons. This first one is not continuous because the left and right hand limits don't agree. And that's what I've written in mathese down here. This one, the limit does exist, but the function is not defined at a, and therefore the limit is not equal to the value of the function. In this one, the limit does exist, the value of the function does exist. So the limit does exist, the value of the function does exist, but they are not the same, and therefore it is not continuous. So those are our 3 choices. Now you'll notice in this one I didn't talk about f of a. F of a exists, but I didn't need to because the limit does not exist. So if the limit does not exist, you don't need to go into a, but if the limit exists, you have to talk about what f of a is and what's happening. So that first condition, if the limit doesn't exist, there's no need to use the second. But if the first condition does exist, it's fine. Then we have to get into the second part. And so that's your two different ideas going on here. Okay, use the definition of continuity to justify and sketch each problem. Is H continuous if A is 3 and B is -3? So I'm going to go ahead and do 4 right down here. And so I'm just going to take, I have a graph. When I'm at -1, it's equal to 3 and everything lower. Then I have a line segment in between. And then when I'm bigger than 1, so this is -1, and here's +1, I'm at -3. So the question becomes what's happening in the middle. Now that I made that way too low. It's supposed to be 3, about the same distance. Okay. So I'm going to go ahead and plug in this equation. So my middle equation becomes 2 times A x plus b. So it becomes y equals 6x minus 3, if you will. So my y-intercept is -3. My slope is 6. So let me plug in 1. So when I plug in -1, y equals 6 times -1 minus 3, which is -9. When I plug in +1, I get 6 minus 3, which is 3. So it's up here at 3. And way down here at 9. And so the middle part is doing this. And it's a sketch, so it doesn't have to be perfect or beautiful or anything else, but it looks like that. And so this is not continuous because the left and right hand limits don't agree. And we have jump discontinuities. It's not continuous. It does not say to use the definition, but we are in calculus class. So I don't want you to use because of a jump discontinuity. I know you just learned that in my class because you didn't really talk about it before, but we need to be using calculus reasons. And officially, any teacher could have mentioned that before we were in calculus. There's a jump. It's not continuous. So that's not really a good reason right now. It's a good reason. It's good. It's just not the greatest reason right now. So we are going to say because the left and right hand limits at -1 don't agree and the left and right hand limits at +1 don't agree. That's going to be our reason. So that's how we do it. Go ahead and try 5 on your own. I'm going to pause the video. You're going to try 5. The answers will be up here in just a minute. And so I had to have a meeting with my sons, and so the picture's gone, so I hope you don't mind. But anyway, here we have, I added no left and right-handed limits because no, it's not continuous, no, because there's no left and right-handed limits are different. So at 1, at -1. So that's for number 4. For 5, that's over here, I drew the picture. So I have the line x plus 3, so I have a y-intercept of 3. It also goes through -3, so it has a slope of 1. And then it's not defined at 0, so I have that open circle at 2, excuse me. And so, but at 2, it's equal to 3. And so the limit is 5 by plugging 5 into x plus 3. The limit is 5, but the function is equal to 3. So the limit as we approach 2 at f of x is not equal to the value of the function at the same time. So that's why it's not continuous. Okay, and this was only supposed to be about 1, so I didn't need to put the other one in, but whatever. We have them both. Okay, so find a and b so the function is continuous for all real numbers. So the idea is to find them, and I'm going to go ahead and do the one with a and b on question 8. So question 8 says that I have 4 and -4, and we're trying to make a line that connects in between those two. So what I know here, that this is a little weird, but I know that I have 2 ordered pairs. So for question 8, I know I have the ordered pair -1, 4, and I have the ordered pair 2, -4. So those are 2 points on my line. So in order to connect these 2 points, one is this from this side and the one from this side, I need to make a line that connects them. And so to find a line that connects 2 points, I need the slope. So I have my y is changing 8 and my x is changing 3. And it looks like y is going down and x is going up. So that's negative. So it's a -8/3. That's my slope. And I did that by doing the change in y, which is 4 minus negative 4, which is 8. And the change over the change in x, negative 1 minus 2, which is negative 3. And there is that. So I just did delta y over delta x. Okay, so I found that with just, and I don't, because the formula makes me crazy. If you love the formula, you can use the formula for slope. I'm not going to give you it, but I just did that, change in y over change in x. So there's my slope, and now we need to find b. So this is a. Okay, and I found that by finding slope. And so my y-intercept needs to make it so that these connect. And so now I'm looking for the y-intercept, and I can just kind of use some basic algebra techniques to kind of figure this out. So this is what I know so far. And to use my basic algebra techniques, I'm going to pick one of the points, and we've got thirds. So it doesn't matter. It's not going to be pretty no matter what I do. So I'm going to go ahead and put negative 4 over here at negative 8 thirds times 2 plus b. And so negative 4 equals negative 16 thirds plus b. And so b equals negative 4 plus 16 thirds, and there are 12 thirds in negative 4, so it's my answer is 4 thirds. Okay, and I'll just double check that, and I'll double check that by checking it out on Desmos. So I'm going to go to Desmos and see what's going on here. So when I jump over here to Desmos, which isn't here anymore, so I'm jumping over to Desmos, and I'm going to graph the two lines. So we had 4 less than 1, negative 4 greater than 1, and then that line that hopefully connects them. So y equals 4, 2, was it 2? I was in a long meeting just now. Not that it matters, but I can't remember anything. So y equals 4 when x is less than or equal to negative 1, and then y is negative 4 when x is greater than or equal to 2. And so you can see that's what I have. And so I'm trying to connect these two endpoints with my equation that I made. And so it's going to be between negative 1 and 2. So right now it's just graphing 1 because I didn't put an equation in there. But that's where I need it to be. And so the equation that I created is y equals negative 8 over 3 x. See, that looks pretty good, plus 4 thirds. Okay, so it looks like I've connected it. And so I've made it continuous by basically forcing this green line to connect the two other lines. Okay, so that's the idea. The other ones are marked. This one's weird because you have to find A and B. The rest of them you just have to find A. So I thought that was pretty good. And so I'm gonna do 6 and leave you to try 7. So with 6, we have this sign and then this thing that takes over. If we think about it, they need to be equal when I plug in 0. So when I plug in 0 to this, I'm going to get 0 over 0, which is bad, but I know that the limit as x approaches 0 of sine of x over x is 1. So that the limit as x approaches 0 of 2 sine x over x is going to be equal to 2. Because the limit, it's not defined at 0, but that's the limit. So I'm going to use 2 as the value of the function at 0. So that means I'm going to set this a minus 4x is equal to 0 when x is 0. Equal to 2, excuse me, equal to 2 when x is 0. And so I have a is equal to 2. So I think this is 2 minus 4x, which makes sense. The y-intercept, I should have actually thought of that. A is 2, and then I would double check this with a graph. So I want to see that I made it for sure. Notice that I'm doing all the work before I check. I'm checking it now with the graph. So I'm going to go ahead and turn these off. And then I have 2 sine x over x, okay? And that's only true when x is less than 0. Okay, I'm going to go ahead and kind of, let's just go back home and we'll just make this bigger. Negative 5 to 5, where's the other one? How about that? That works. Okay, so let's kind of look at that. And so then my other equation will be 2 minus 4x. And it looks like it connects just fine. X is greater than or equal to 0. Okay, so that looks like it worked. So that's the idea. So I can check that if it worked there. Go ahead and take a minute, pause the screen, and try 7. Okay, so I went ahead and kind of set this one up similar to this where I'm finding the limit of the numerator. And x minus a will cancel out because I can factor x squared minus a into x plus a and x minus a. So I'm left with x plus a, which is a plus a, which is 2a. So 2a has to be equal to 6, which means a is 3. So I've created in Desmos, when I haven't actually checked it to see if I was right, I've created this. And so if you see, I have, there's my line 6, and supposedly 6 is going to fill my hole, and my hole occurs at a, whatever a is. So if I add a slider for a, this is going to be a line, because it's going to be x plus a, so it's going to be a line with a slope of 1 that goes through a. So you can see right now it's going through 1. And while it's going through here, the hole in this is at 1. So you can kind of see that the hole, my cursor's totally in the way. The hole here is at 1. So that line didn't fill the hole. So if I move this up, we're step by ones. So if I move this up, okay, and so if I move it to 2, now as I trace across it and I click, there's a hole at 2, so it's not filling the hole. So let's try 3. And so now I'm on the blue line. I need to not be on the blue line. On the red line, on the red line. See how there's no hole because it's filled up. So, yep, if A is 3, I'll fill up my hole. That one was a little bit weirder than the other two because you had the 2 variables and it was doing something strange, but that's the idea. And so we have solved this set of problems. We got a few more and then we're done with this video today. So in the following problems, a function f and a closed interval a from a to b are given. Determine if the intermediate value theorem is true. Holds for the given value of k. If it is, find a number of c such that f of c is equal to k. If it does not, give a reason. So this is our really kind of our first practice. It's okay if we don't know what to do. It's all good. Let's go ahead and just start at the beginning. So we've got an interval from 0 to 3. This is a continuous function. Okay? Across the entire domain because it's just a quadratic. It's all real numbers are its domain. It's no problem. So it is a continuous function. So no worries there. We're going to go ahead and find f of 0, which is 2, because 2 plus 0 minus 0. And then f of 3 is going to be 2 plus 3 minus 3 squared, which is 5 minus 9, which is negative 4. Okay, so f of 3 is negative 4. And we want to know if it's true for k. Well, k is between 2 and negative 4, so we know. Since it's continuous, is continuous on the interval 0 to 3. And f of 0 is 2, and f of 3 is -4, and k equals 1 is between 2 and -4, -4, IVT is valid. So now I've decided it's valid. So that's how I decide. Now I need to find the answer. So I'm going to I need to have it equal 1. K is the output. So notice I'm trying to find an input that gives me K. That's what we're asking for, is an input that gives me K. So what I'm going to do is K is my output. So 1 equals 2 plus x minus x squared. So the first thing I'm going to do is I'm going to play a little game. So I'm going to add x squared to both sides, x squared. I'm going to subtract x, and I'm going to subtract 2, which will give me -1. So I added, subtracted, and subtracted. And now I have this equation. So I'm going to factor that. It's factorable. X minus 1, x, nope, it's not factorable. No two numbers multiply to make -1 and add to make 1. So now I'm using the quadratic formula. And so I have -b plus or minus the square root of all that stuff. So -b, which is 1, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. 2 times a, which is 1, which is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is 1 plus or minus the square root of 5 over 2. And so, which one is in the interval? So the square root of 5 is bigger than 2, okay? Square root of 5 is bigger than 2. So 1 plus a number that's 2.5, that's a lie, but 1 plus a number bigger than 2 is bigger than 3. And 3 divided by 2 is between 0 and 3. 1 minus a number bigger than 2 is negative, and so that will fall outside of this interval. So my answer for C is 1 plus radical 5 over 2, because the other answer that I got here, because I remember I got 2, the minus answer is not in that interval. So C has to be in that interval, and so there I am. Then I'm done. So that's pretty intense. So you'll notice that I've basically taken this whole problem just talking about number 9. So I'm going to go ahead and put a big rectangle on what I didn't talk about, because it's going to be in my way and makes me confused and frustrated. So I'm just going to kind of cover those up. So all I did was 9 here. So it was very intense. It's a very involved process. I'm going to figure that out. So jumping too fast. So it's very involved. So the idea here, though, is that's what you have to do. You have to establish that IVT holds, which is all the blue writing. And then you have to let K be f of x so you can find C. So it's kind of funky. Like, really, I should have said C in the whole time instead of x, but whatever. So let's see if we can try again. So I'm going to go ahead and put the rectangles on now so things are not in my way. I'm going to go ahead and cover up 9 because we did that already, and cover up 11, and let's see if we can do 10. So this is not continuous on every interval. Since it's 9 minus x squared, it has to stay positive. So that means x squared has to be in the right range. So if you think about this particular 9 minus x squared, it will be positive as long as x is less than 3 and bigger than -3. So it has to be between -3 and 3. It can be equal. And so this is in that interval of continuity, so that's okay. So that's sometimes that can be really tough to establish continuity. But this is a function, it's basically half a circle. 9 minus x squared is half a circle. And so it's the top half of a circle between -3 with a radius of 3. But again, that kind of takes some time to get used to what you're seeing. So there, that's how it just, so I know it's continuous. Step 1. Step 2, and I'm going to find f of A and f of B. So A is -2.5 or -5/2. It might be easier to use. It is for me. And then, so that's going to give me 9 minus 25/4. Easier to square that, which is then 36/4 minus 25/4, which is 11/4. Square root the whole time. And so then I have the square root of 11/2. Okay. And the square root of 11 is a little bigger than 3. So, you know, we might want a decimal for that in a minute, but that's f of -2.5. So then we need to find f of 3. That will be easier. F of 3 is 0, but let's go ahead and go through the motions. 9 minus 9, so it's equal to 0. Okay, so is k in the interval? Well, I go from 0, which is the smaller one, to this, and I said this is bigger than 3. 3 divided by 2. We need to figure out what that decimal is. So let's get a calculator and figure out what that decimal is. Okay, not the greatest calculator in the world. It's not my favorite, but I do have the square root button, so I need the square root of 11. Square root is, like I said, bigger than 3, divided by 2, which is smaller than 1. So k is not in my interval, so it doesn't matter. So this, which does not surround k equals 2. So IVT does not apply. So I don't have to do as much work, but again, establishing that IVT applies is part of that work. And so the intermittent value theorem does not apply because this is 1.65-ish. So the IVT does not apply. Okay, so that was 10. So one more. Okay, so we got to get our rectangle out. All right. So continuity. This is just continuous when x is 1. And so from 2 to 5 it's continuous. What form? From continuous everywhere but unless x is 1. Okay, so it's definitely continuous from 2 to 5, so it's continuous. Check. Second, now we're going to plug in, so we're going to find f of 2. F of 2 is 1 minus 2, which is 1. F of 5 is 1 minus 5/1, which is 1/4. So that's 0.25. So from 0.25 to 1 is my interval. And 5/6 is less than 1, but definitely bigger than 1/4. So this is in the interval. So the IVT applies. So since f of x is continuous from 2 to 5 on the interval, I'm just going to say on because it says closed interval from 2 to 5, and f of 2 equals 1 and f of 5 equals 1/4, which surrounds k equals 5/6, the IVT applies. So now we have to figure out what C is. So now when f of C equals 5, 6. So 5, 6, well, let me change colors. So there is a value C. We just need to find it now. So f of C equals 5, 6. So 1 over C minus 1 equals 5, 6. So I'm going to cross multiply. So 6 equals 5C minus 5. So 11 equals 5C. And C equals 11 over 5. Okay, that's the idea. So you'll have plenty of practice with the process of finding C on the website. Lots and lots of practice. So enjoy it. It should be good. And good luck to you. We'll talk to you guys soon.